Well, hi, this is Rich with Inside HPC. I'm here today with Shaheen Khan from OrionX. Shaheen, good to see you again.
Good to see you, man. How are you doing?
Well, Shaheen, you gave a recent talk that kind of spanned a lot of different technologies, but today I wanted to focus on quantum computing and get your take on it, at least in terms of what you're talking about at the Stanford show.
Our one-page summary of quantum computing is that it's all about everything being a probability function. Somebody put it really well that it is simultaneously overhyped and underestimated. And that is so true. It is very hot. It's going to remain hot, but there are still obstacles and it's still kind of very much Wild West. The current state of the market is characterized as NISQ for noisy intermediate scale quantum computing. And there are a lot of different ways of achieving it. You want these probability functions that you can harness. And then at the other end, what you really want is a universal quantum computer. Currently, there are really two ways of doing it. There's a gate model, and then there's a quantum annealing model. And the gate model is gaining a lot of favor and endorsement in the market. But even within the gate model, there are a number of different technologies, and it's too early to tell which one is going to be good at what.
So there's, in that aspect, are there active vendors in each of these segments now, or is it still too soon?
There are. Basically on the quantum annealing side, of course, we've had D-Wave as one of the early movers, probably the first mover in that market, and continues to do very good work. On the quantum gate model is really a lot of other people. We have seen obviously IBM, one of the first players there. We all know that people like Google and Microsoft have their own projects. Rigetti is one of the newer players, but pretty well established at this point. There are new players like IonQ, and then recently Honeywell came in with their trapped ion system that is doing, that's looking pretty promising. But I want to also paint a picture on that. That kind of calls into question, how do we categorize these accelerators? So the picture that we're looking at right now is our proposal to do this. This is a collaboration that I had with a semiconductor company out of Stanford called Radical Semiconductor. But it basically paints the picture as digital versus analog, and then classical physics versus quantum physics. And that gives you a 2x2 diagram. So the upper left quadrangle is digital classical, and that's where we are today. That's clusters, GPUs, FPGAs, TPUs, etc. And within that world, we are looking at parallelism, and increasingly we're also looking at non-Turing machine kinds of implementations, whether they're in memory or just a different kind of model altogether. And also algorithmic ways of getting speed. The bottom half of that chart is essentially quantum computing, with quantum gate on the left, quantum annealing on the right. And then the upper right-hand quadrangle is also something we're keeping track of. And that's the so-called mixed signal accelerators, where you have analog circuitry aided by digital circuitry to go solve the problem.
So a whole span of approaches towards the same kind of science, it sounds like.
Very much so. Now, of course, this is accelerators only. They're all counting on hanging off of existing supercomputers. And some of them basically get you to the 5-yard touchdown really fast. And then you go back to the normal way of doing things to get the last mile, mixing several metaphors there. Some of them actually attempt to solve it all the way. And it's important to really keep track of all that Cambrian explosion.
Yeah. Well, Shaheen, I know that we could talk about this at length, but we're doing these coffee break short things. And
we only got 5 minutes.
We only got 5 minutes. So yeah, we solved all the problems of the universe. And I really want to thank you for coming on the show today and telling us more.
Thank you, Rich. Great to see you again.
You bet. Take care.